Oh, howdy. So recently my sister asked me a question for her math homework, and I obliged because I'm such a great brother. And um, her thing was about reflections across like different axes, like x-axis, y-axis, and then lines. And so she had a shape and whatnot across the line, but I'm gonna, for this example, give just a point P. So point P is just Px, Py. Okay? And to reflect it across the x-axis, her sheet had said that P prime was equal to negative Py Px. So the y and the x are flipped, and oops, and they're both negative, which makes sense to me. But something I noticed was, wait, actually, is that correct? Did I get that right? Y becomes the x, negative x becomes, it should be here. No, it should be here. That's where P prime is, so just ignore this. That's P prime. Sorry about that. Yeah, that's P prime. So, I noticed that this right here, as I was looking at this length was equal to, in squares, by the way, not in like decimal, like it was like, not squares, in diagonal squares, it was Py plus Px divided by 2 is the length of 1/2 of this line in diagonal squares. So, like, if you were to count, like, there'd be little grids here. It'd be half of a square. Like, this would cut a square in half. So then, and these squares were 1 by 1 in length. So, I was like, why is that? Like, I was looking at it, and I was like, oh, okay, I see a pattern. Let's investigate the pattern. So, first what I did is I can say that this is Py tall. And then I can say that this is Px tall. Now why can I say that? Because this is y equals negative x. Our x value is Px. Therefore, at Px, it's Px comma negative Px. If this is negative Px, then that means it's Px from the x-axis. Makes sense, right? So then for the for the x distance, this is also Px, and this is Py. Why is this Py? So if the y is Py, then the x, you multiply by -1, and you get negative Py for the x. So x equals negative Py. If this is negative Py, that means that it is Py distance from the y-axis. Doesn't that make sense? So, and this length from here to here is L. From here to here is L. And we're going to call from here to here C. So let's draw a separate diagram. We go this way across, this way there. So we have C, and then at a right angle, and we know it's a right angle because if you rotate around something, you're not going to be shifting like relative to it. So it must be in the same like line if you rotated it around. So we'll draw a right angle there. L. So then Py plus Px, Px plus Py. Right here. So, I think you can all see where I'm going with this. What do we know? We know that Py plus Px squared plus px plus py squared equals c squared. That's the Pythagorean theorem. See that right triangle? This is also a right angle. But this right triangle, a squared plus b squared equals c squared. And also, since py plus px equals px plus py, we have 2 py plus px. So that means that 2 times py plus px equals c squared. Now this is important. I'll highlight this. So now we know what c squared is. So we also know from the second smaller right triangle right here, with length c over 2, because it bifurcates it because it's at a right angle, and it should cut it exactly in half if it's cutting in half of another right angle. I don't know the exact geometry behind that, but I know that that is true. At least I know it's true because it worked out in this case, but I kind of just went off intuition. It looks like it cuts in half. So then this is c over 2. That's L. That's px plus y. So we have a second right triangle. Oh my god. So that means that L squared plus, L squared plus c over 2 squared equals px plus py squared. Right? The length a squared plus b squared equals c squared. And this is this is c squared because it's opposite the right angle, and that's just like what the hypotenuse is. This is opposite the right angle. So, how do we put these equations together? Well, we know c squared. We know that this is c over 2 squared, meaning it's c squared over 4. So we're gonna we'll just plug this in. So we get L squared plus c squared over 4 equals px plus py squared. Now plugging in that c squared equals 2 times py plus px, we get L squared plus 2 times py plus px divided by 4 equals py plus px. So we're going to multiply by 4 because that's just going to look cleaner. Just multiply everything by 4. So then we can subtract this over because these are just the same. Sorry, oops. Forgot to put that there. That's an important aspect. Totally forgot to put that there. Sorry. It's 2 times py plus px squared. Sorry. So then you subtract this over. 4l squared equals 2 times py plus px squared. Why is it 2 times py plus px squared? Because 4 minus 2 is 2. So 4 of this minus 2 of this equals 2 of this. Does that make sense? So then we can divide by 2. So 2l squared equals py plus px squared. L squared equals py plus px squared divided by 2. L equals py plus px divided by the square root of 2. Which is not our final answer. That tells us the length, like in decimal. Like if I were just to draw this, that tells me the length if I were to then flatten it out. Which is not what we want. We want the length in terms of diagonal squares. What I mean by that, by the way, is, I'll draw it over here actually. If I have like, this is like the grid and whatnot, you know, this is, you know what, actually I'm going to cut it right here. This is 1/2 of a diagonal square, 1 hole, 1 hole, 1 hole. So this is 3.5 diagonal squares. Does that make sense? Once it reaches the diameter of the square, then that's half a square. That's a full diameter or full diagonal square because it goes all the way across it diagonally. So, how do we convert this to diagonal squares? Well, we know that the length is py plus px divided by square root of 2. Now, let's say this is just in meters, like just to give it a unit. Or no, let's just say it's in units. So, we have this many units of length. Now, we know, let's put this up here just to do the conversion. So, a square that is 1 unit by 1 unit is going to have this diagonal length be the square root of 2 units. This is because of the Pythagorean theorem again, right here, because 1 squared plus 1 squared equals c squared, 2 equals c squared, c equals the square root of 2, c being the hypotenuse, which is the side that is opposite right angle, meaning this is square root of 2. So, for every 1 unit, which is like 1 grid, like one little like grid length, we have square root of 2 units. So then, we now have a conversion factor, which is that every 1 unit square root of 2 diagonal squares passes. I believe, unless it's 1 unit. No, it's 1 unit, because then this is unit squared plus unit squared equals c squared, which is going to be diagonal squares. So then c is going to be in terms of the square root of unit squared, which is units. So yeah, it's going to work out that way, I think. This part, I'm like, it works out, but it is odd, I will admit. Wait, this is not right. Yeah, this is not right. Let's just do this in meters. We have so-and-so meters. Okay, it was a bad example. We have so-and-so meters times every 1 meter every square root 2 meters is 1 diagonal square. That makes sense. Yeah. So every square root 2 units is 1 diagonal square. Yeah, there we go. Sorry for that. So then if we were to do this again with the unit thing, we would multiply by that. We would multiply that square root 2 units is 1 diagonal square length, meaning that to convert this to diagonal square as ds, we have py plus px divided by square root of 2 times square root of 2, see, equals py plus px divided by 2. And that gives it to you in diagonal square units, which is the exact same pattern I noticed while I was looking at this earlier. Confirming that it is true. So, I'm not really a math teacher. I just do math sometimes.